Welcome back to rational functions. This is part 3. We're going to find the wholes and asymptotes of a function, rational function, algebraically. So the first thing we're going to do is find the wholes of this function. F of x equals x squared plus 5x plus 6 divided by x squared plus 6x plus 8. We are going to factor both the top and the bottom. So this is going to be equal to, factoring the top, factors of 6 that add to 5, is x plus 2 times x plus 3, the factors for that. And the bottom actually factors to x plus 2 and x plus 4. And we see that x plus 2 and x plus 2 cancel. Now if something cancels like this, so x plus 2 cancels, and you set it equal to 0, it's a whole. So we have a whole at x equals negative 2. So in our function, there's going to be that little whole that I showed you in the last part, at x equals negative 2. Now with a whole, you can't just say, hey, there's a whole at x equals negative 2. You actually have to show the y value as well. So you need to find the y value. You take the new form of your canceled, your in least terms form of the function. So that would be x plus 3 over x plus 4. And you put in where your whole is at. So your whole is at negative 2. So this is, when x is negative 2 and we're putting this in, negative 2 plus 3, negative 2 plus 4. So negative 2 plus 3, that's going to be positive 1. Negative 2 plus 4, that's going to be 2. So this is our y value of our whole. So we have a whole at the point negative 2 and y value 1/2. So that's how you find a whole algebraically. Sometimes they'll only ask you to find it where the x value is at. Sometimes they want it as a point, in which case you will need to find the y value, and you'll need to know how to do that. So, next, if a factor in the denominator can be canceled, it is a whole, which we just discovered. However, if it can't be canceled, then it is a vertical asymptote. So, if we look back at what we've done here, we found the whole for this function. But this x plus 4 doesn't cancel on the denominator, which means that at x equals negative 4, there is a vertical asymptote. So whatever doesn't cancel, whatever is not a whole on the denominator, is going to be a vertical asymptote at that area. So we can see this in another example. So here we have 4x divided by x over x plus 1. So we see that one thing can be canceled, that's x. So x can be canceled, so we have a whole, and if we set that equal to 0, then it's just x equals 0, which means we have a whole at x equals 0. So if we're going to find the y value, we're going to put in 0 into our new function after canceling our x. We're going to put in 0 for our x, 0 plus 1, and it's just going to be 4 over 1, which is just 4. So our whole is at 0, 4. And whatever doesn't cancel, so the x is canceled, but the other thing on the denominator was x plus 1, that's going to be our vertical asymptote. So we're going to set that equal to 0. Set that equal to 0. We have x is equal to negative 1. And this is our vertical asymptote. You can have multiple vertical asymptotes, but this one just has one. So that's a vertical asymptote. We're going to talk about horizontal asymptotes and oblique asymptotes. These are more complicated. They follow this kind of rule here. So if we have a function f of x equals ax to the n plus b divided by cx to the m plus d, it really deals with the degrees of the numerator and the denominator. And what we mean by degree is the biggest x. So here we have x to the n, and whatever n is the exponent. The biggest exponent of the polynomial is the degree. So here we have degree n and degree m. So we're going to look at the degrees of our x's. So, and that determines whether it has a horizontal asymptote or not, or an oblique asymptote. So if the degree of the numerator here is the same as the degree of the denominator here, the biggest x with the biggest x with the biggest, the x with the biggest exponent is the same on the top and the bottom, then the horizontal asymptote is the ratio of the leading coefficients. So that would be y is equal to whatever number is in front of the x with the biggest exponent on top and the bottom. So here it's a over c. So that's if they're equal. If the degree of the numerator is smaller than the degree of the denominator, then the horizontal asymptote is y equals 0. So at any time it's smaller, it's just the horizontal asymptote is y equals 0. If n is greater than m, so if the degree of the numerator is greater than the degree of the denominator, there's no horizontal asymptote. But there might be an oblique asymptote. So you have to check for that. If the degree of the numerator is equal to the degree of the denominator plus 1, if m is greater than m by exactly 1, then you have an oblique asymptote, and you'll have to use long division to find out what it is. So it would be y equal to this entire thing divided. So we're going to do some nifty examples to make this make more sense, hopefully. So we're going to find the horizontal asymptote or oblique asymptote of this function. F of x is equal to 1 over x plus 8. So what we need to do first is we need to figure out what n and m is, our degree of our numerator and our degree of our denominator. So we notice that on top we just have the number 1. That means that we have x to the 0. Anything to the 0 is just 1. So our degree on the top, our n equals 0. And on the bottom, our degree, our m, is 1. So we see our n is 0 and our m is 1. So there's a little miniature 1 here. So our x. So we can see that n, they are not, first of all, they are not the same. N does not equal m. 0 does not equal 1. But n is less than m, right? 0 is less than 1. Which means we're going to follow this rule right here. If n is less than m, then the horizontal asymptote is y equals 0. So this function has a horizontal asymptote, and because of this, it is just at y equals 0. Because of that. So the next example, we have this function right here. F of x equals 6x squared plus 2x minus 8 divided by 3x squared plus 8. Let's find the degree. So, has to be the biggest x. So there's an x here on this numerator, but we're going to look at the one that has the biggest exponent. So here, we have the polynomial is degree 2, or you can either say our n equals 2, like that. And here, our biggest x is also 2. So our m is 2 from here. So 2 is equal to 2, n is equal to m. So we're going to follow this rule right here. So n is equal to m. Therefore, there's a horizontal asymptote, and it's where y is equal to the ratio of leading coefficients. So whatever comes in front of the biggest x divided over itself. So here our a is 6 and our c is 3. So it's going to be y equals 6 over our c, which is 3. And we can simplify that. 6 divided by 3 is 2. So we have a horizontal asymptote at y is equal to 2. Right? So that's our second example. Moving on to this example, we have f of x equals 5x squared plus 4x plus 1 divided by x plus 1. So our degree here, so our n on the top, the biggest x is 2. We have x squared, that's the biggest exponent of our x. So we have, this is degree 2, our n is 2. On the bottom we have the biggest x is just x to the 1, like that. So our m is 1. And we see that 2 is greater than 1, so our n is greater than m. So we are going to follow this rule. So we have n is greater than m. So there's no horizontal asymptote. However, we have to check this caveat. If n is greater than m by exactly 1, then we have an oblique asymptote. So if we go back here, 2 is greater than 1 by exactly 1. If you add 1 to 1, you get 2. So because of that, we know that we have an oblique asymptote. So we need to find out what it is by using long division. So we're going to have to find out what it is. So that means that we have to take this and divide it by its divisor, I think. So we have 5x squared plus 4x plus 1 divided by x plus 1. So this will be a review of long division as well. So what we're going to do with long division is we need to figure out what we multiply x by to get 5x squared. So first we need a 5. I'm going to write that on top. I'm going to draw a little line here. And we're also going to need a 2, an x, to get 5x squared. So if we take 5x and we times it by x, we get 5x squared. And we also have to multiply it by this. So we have plus 5x. And then you're going to subtract from the original polynomial here. So you're going to subtract this entire thing. Okay? This negative, so 5x minus 5x squared, that's going to be 0. This negative also has to come over here, so this is not positive anymore, it's negative as well. And so we have 4x minus 5x, that's going to be negative x. And then we're going to bring down the 1, plus 1. So next we look, it looks like we can still multiply something from this first leading x to get this. So we can multiply negative 1 by this x to get this negative x. So I'm going to put that here. So negative 1 times x is negative x. Negative 1 times 1 is negative 1. And we're going to subtract from the entire thing. So this is going to be positive x. After we do this, it's going to be positive x. Negative x plus x is 0. If we multiply this by negative, it's going to be positive. 1 plus 1 is 2. So we don't actually care about remainders. This is the remainder, it's a remainder 2, but we don't actually care about them. All we care about is this result right here. Set that equal to y, and then you have your oblique asymptote. So our oblique asymptote is the line of y equals 5x minus 1, whatever the result of our long division was. So I have one more example for you. So here we have, so now we're going to go back to our little handy dandy sheet. The degree of our numerator is 3, so our n is 3. Our biggest x is 3. And the degree of our denominator, our m, is going to be 1. So our m is 1. So if we look at that, we have our n is greater than m. So there's no horizontal asymptote for that rule, but we have to check if there's an oblique asymptote. So if n is greater than m by exactly 1, then we have an oblique asymptote. But we see that if we add 1 to m, it's 2, and n is still greater than it. So because it's not, it doesn't fulfill this rule right here, 3 does not equal our m plus 1. Because of that, there's no horizontal or oblique asymptotes. No horizontal asymptotes or oblique. So that's also a possibility. And with all of this, you should be able to do all of the problems on your study guide. Thank you.